Okay, the next stage of the aggregation pipeline I want to tell you about is the match phase. Now, match performs a filtering, which is an n-to-1 operation. Match will go through each document and see if the document matches your criteria, and if it does, then it will push it through to the next stage of the aggregation pipeline. Now, there are two reasons why you might want to match. The first is that you might want to filter the documents and only perform aggregation on a subset on them. And the second reason that you might want to perform a match is you might want to filter the results itself, which is to perform an aggregation, and then after that to filter the results. All right, let's look at the zip code collection and see how this might work. So here's what the zip code collection looks like. It's got one document for each zip code, which is in the underscore ID, with a city and a location and a population and a state. Now let's say we wanted to filter this data set and only aggregate on documents in a particular state, let's say the state of California. This is a document for the state of Alabama. California has an abbreviation of CA, so we're going to filter on that. Here's how we would do this using aggregation. Now this is a small script in Emacs here. First we use agg, then we call db.zips.aggregate, and our aggregation pipeline only contains a single phase, which is a match phase. And you can see here that this is in square brackets, so the aggregation pipeline stages are part of an array, and there's only one in this case. And the match is specified right here, and it's very similar to the way you would specify criteria for a find command. We're saying that the state needs to be California. There you go. Move the cursor so you can see the quotes. Let's run that and see what happens. Okay, so I ran that, and you can see that the results now, that every document that we see that's produced by aggregation is California. Now that we've reduced our data set down to just California, we can perform a grouping and get the population for each city by grouping on the city. And I'll show you how to do that. All right, here's how you would first filter for California with the match, and then we have a comma here. This is the second element in the array in the pipeline. And now we're going to perform a group operation in this stage of the pipeline. We're going to group on the city, and we see that it's $city to pull the city field out of the document as it passes by. And we're going to aggregate on the population $pop. If you remember the documents, pop was where the population of each zip code was held. And then, just for fun, we're going to also keep track of all the zip codes that are included in a city. And we do this by defining a new field called zip codes, and then using the aggregation operator add to set and aggregating on the underscore IDs. And the underscore IDs themselves are going to be the zip codes as the document passes us by. So again, we're grouping on the city, and as we look at each document, if the document is in a particular city bucket, we're going to add its population to the population field, and then we're also going to add the zip code to a zip codes array. And if we do that, let's see what we get. Okay, so now we see the documents have been aggregated on city. So for instance, we have Termo and Standish and Ravendale and its population, and then you can see that there's a list of zip codes that are included in that city. And for these particular cities, it looks like they're all single zip codes. They're very small cities. But I think if we go toward the top, there might be one that has multiple zip codes. Yes, Truckee has a population of 9743, still a small town, but it includes 2 zip codes, and you can see we built this array of zip codes. But this document isn't very pretty because rather than saying city here, instead it says underscore ID, and that's just the nature of aggregation, that you have to define an underscore ID that you're going to group by. So if we want to have this be a little bit prettier, we can reshape this document to essentially rename the underscore ID field to city. And we can do this through projection, and let me show you how that works. Okay, so right here is the same aggregation query, but this time we have one more stage. So we have our matching stage to filter only our documents in California right here. We have our grouping stage to group by the city so that we can get the population, and that's how we wound up with the underscore ID in the result. And now finally we're going to reshape these documents, which is a one-to-one operation. And in this projections stage of the pipeline, we're going to suppress the printing of underscore ID. We have underscore ID 0. And we're going to define a new field called city. And that new field uses the $underscore ID value. So it's basically a reshaping of the document, a renaming of the document. And we're going to include the population which we did by saying population 1, and then we're going to include the zip codes by saying zip codes 1, and that says include these things in the final result, and that's going to reshape our result to look a little prettier, and let's see how that looks. Okay, so now we've reshaped the document, and you can see that the population is here, the zip codes are here, and the city is here. You'll also notice that MongoDB did not retain the original ordering of the fields. So in our previous result, the underscore ID came first, and now the population came first, and then the zip codes, and then the city. And this is different than what we actually specified. We had city, population, zip codes, and we got population, zip code, city. So the projection step will specify which fields you want to bring through to the final result, to the next stage of the pipeline, I should say, because you could aggregate further from here, but it does not retain the order necessarily. Okay, now it's time for a quiz. So thinking again about the zip code collection, which we've been playing with, write an aggregation query with a single match phase that filters for zip codes with greater than 100,000 people. And you may need to look up the use of the $greater than operator if you've forgotten how to do that. I put a link to it here in the docs. The way I found this, by the way, is by typing $GT space MongoDB into Google. So Google is your friend when it comes to looking up the MongoDB documentation. So write that query right here.